I thought I'd start with a definition of creativity and then throw it away, because it's always a good idea to say, what do we mean by creativity? It means different things to different people. And this is actually from Wikipedia, which means I don't have to pay any copyright fees for using it. Wikipedia says it's a mental and a social process involving the generation of new ideas and concepts, or new associations of the creative mind. Notice talk about not just concept, but mental and social concepts. And then there's this idea that creativity is fueled either by something that you do consciously or unconsciously. And then there are those who say that's too fancy, it's actually just about doing something new. Okay? And then some other definitions. How many of you have heard of Clayton Christensen from Harvard Business School? Okay, Clayton's written quite a lot of books about disruptive technology, creativity, etc. And so it's always interesting to see what other people say, right? And he just describes it, he then brings in the idea of a disruptive technology. So what he's saying is that lots of technologies, if you're really trying to be creative, change things, the idea of disruption is very, very important. Okay, so he talks about disruptive technology, disruptive innovation, and he defines that as basically something that changes things. And his definition says you improve a product or a service, or you design it for a different set of customers. And I've added, or doing something very differently. Okay? You won't find that in his definition, but I did that because I think that's important. And then this is a simplification of Clayton Christensen's view, which is he says that you have on one axis you have a performance of something you're trying to do in time on the other axis, and he defines this nebulous term of low quality use, medium quality use, high quality use. How many of you have read, you're probably far too young to be aware of this book, but have you heard of a book called Zen and the Art of Motorcycle Maintenance? Robert Pirsig. There's a classic literary text. And in that book, he says he sets out in the search to understand the meaning of the word quality. What is quality? And he still hasn't answered it. He had a nervous breakdown after he wrote the first book, didn't write anything for 20 years, and then wrote a subsequent book of philosophical inquiry. And he talks about how quality and the perception of change and values is really part of the creative process. And there are some wonderful anecdotes. If you get a chance to read it, I'll have to repeat one for you. He goes to an Indian reservation, an North American Indian reservation, and he says to this woman there, what sort of dog is that? Because he sees his dog wandering around. And the woman says, it's a good dog. And he says, no, what kind of dog is it? And she says, no, it's a good dog. And what he's trying to show is that our perception of classification and quality, as far as this woman is concerned, the fact that it was good was much more important than the kind of breed it was or whatever else. And it's all about perception. Okay? So here's a simplified view. And then really we start to get much more practical, which is, so how does creativity manifest itself in terms of the subject of our talk today, in terms of technology? What does it actually mean? It means you can use technology to create a new product or a service. You're doing something new. Examples that abound. So, for example, the iPhone from Apple. Very little of that technology that actually sat in that wasn't already available. But the way it was applied to create a novel product was important. The second way in which is very important in the context that we're talking about today is that the technology changes the way in which a product is bought or sold or provided. So it may be the same thing, but you're delivering it to people in a very different way. And a good example of that would be software. Until about 5-7 years ago, the predominant model for the way you bought software was you paid a software license, you installed a new machine, you run it. Today, if you look, we have things called software as a service, rental models. You pay a subscription to use software for a period of time. That changes so many things. It's dramatically going to reorder the software industry. Not because the core product has changed, but because of the way it's being sold or delivered to customers. And then the third is really the way in which which the services, distribution channels, how it's bought, sold, delivered into people. Distribution channel really defines the way in which the product goes from the factory to the customer. So if I give you another example of that, you look at mobile phones. When mobile phones were first launched, you went and bought a mobile phone from a shop. You paid £400 for it, or more, I remember we designed the first mobile phone at PA in 1986, and it was the size of a brick. And it wasn't mobile at all. And then you probably remember the cartoons from 1989, 1990. There were people in the city would go around with this great big mobile phone held to their ears, and it was like a badge of achievement. And you think what we have today. But that mobile phone, the old model was you went and bought one, and then you got to connect it to your network. What's the model today of distribution? You basically sign up with Orange or whatever else, or you walk into a retail shop and they'll give you the phone, and you either buy a prepaid SIM card. The entire distribution has changed. And so instead of these phones reaching you through retail outlets in this way, they arrive with couriers to your door with a SIM card, and you phone up a number and activate them. So the distribution models have changed. That changed the economics of the whole system. So creativity, doesn't just have to be in the way a product's created. It can be in the way it's sold, how it's paid for, or how it actually is delivered and used by people. Okay, so what I'm going to do is talk about two case studies, and they're different examples, and I'll just spend 2 minutes explaining each of those case studies and talking about the difference. So the first one is a company called Design Force, and so if I kind of declare my colors, I'm actually chairman of this company now, and I was involved in its creation over the last 3.5 years. What it's done is, the idea is to change the way in which engineering designers design products from simple to complex things. Everything from an aircraft blade to a car to a new pencil. Okay, and we'll talk about how novel models and novel distribution channels are changing that. So it's very high end. So it's about stuff that might be used by people like Rolls-Royce or aerospace designers, very high tech. It's the kind of thing that Cambridge University professors, the Whittle Lab and others wouldn't turn their nose up at. They would say, oh, this is great, this is real high tech stuff. The second example is right at the other end of the spectrum, and that has also had Cambridge involvement. And that's really a very interesting development of a low-cost product for food chilling. And the phrase bottom of the pyramid you see up there, bottom of the pyramid is a term that Clayton Christensen uses, but it's very, very popular in the developing world. You can't go around India today without talking to anybody in strategic or commercial terms without them mentioning BOP, bottom of the pyramid. And the idea is to bring technology-driven innovations to the masses rather than the very narrow middle-class elites. And same is true across swathes of Africa, Mexico, everywhere else. And the paradox, of course, which is not a paradox if you understand the way creativity works, is many of these products and services and then coming back into European markets because of changing conditions. So the Nano, which was designed for a low-cost environment for the Indian market, is now going to be sold in Europe and will probably do very well. Okay, so, and the second example is actually the company is Godrej. And those of you with any Indian background will know Godrej is a very large white goods manufacturer in Asia Pac based out of India. And they do everything from refrigerators to safes, to cupboards, to locks, to furniture. And this is a very, very new product for them. But historically, most of their products have been bought by the middle classes in India because of the cost point. Okay, so those are the two things we're going to talk about. And for those of you who like to go and read up a bit more about the stuff, innovation and creativity is a diffusion process. Have they heard from Jack Lang, this group? Okay, well, Jack goes on ad infinitum about diffusion, innovation being a diffusion process. It's his great passion. But the whole theory of diffusion, which follows the bell curve, was described by Everett Rogers in 1962. And that's an interesting read by way of background if you're interested in the field. The other thing to read about is Geoffrey Moore's book, which talks about crossing the chasm, which is the chasm going from early adopters of new technology products to mass markets. And that's quite interesting. And then there's some work that I've been doing with some people to say there's more than one chasm based on our practical experience of building businesses. There are two earlier chasms in taking technology ideas into prototypes and then turning them into early products before you go to mass markets. Okay, so that's the end of the background, and so if you thought that was theoretical, that's theory as far as I'm concerned for today. Okay, So this is, it's called the on-demand. Every word has a meaning there. On-demand means you can go online over a broadband connection and use the service. Radically transforms the way in which you look at using design tools. Instead of buying a cray and installing huge amounts of software and having IT people tune it, etc., you basically go to a web URL, type in your password, and you have access to all this capability on demand. And the design optimization aspect relates to the fact that you typically have three phases when you're designing something. You design it, you simulate it, or you build a model of it, and then you can optimize it. And historically, you design something, then you build several models, and then you test them to destruction, you change the design again, and then you have a final answer. If you look at how Formula One operates today, you know, Lewis Hamilton's car and the aerodynamics of that car, they basically, until about 3 years ago, what they used to do, they would do the design work, they would build models, test them in wind tunnels, then they'd change them again, go back, etc. The design cycle was very long. Now, the Formula One guys have more computing power than Rolls-Royce. They have banks and banks of machines basically crunching numbers. But the point is that they can simulate the designs that you still can't optimize, so they might need to run 100 variants. What this service does is automatically iterate down to a solution that you would define the criteria for optimization. So a little like a hill climbing technique. For those of you familiar with the hill climbing algorithm, you know, if you're climbing a hill, you can go in many, many ways up a hill, but there may be an optimum path up a hill, which is the opposite of what mountaineers usually like to choose because they want a challenge. Okay, so talk about creativity, because what I wanted to show you was how the early process of creativity works. So what happened in this particular case was, and this is 3 years ago, I met one of the professors in the engineering department from the University of Southampton, who basically said, I've got some wonderful grid computing technology. Basically what it means is you connect together a whole bunch of PCs, wire them together, run the correct software, and you get the performance of a supercomputer by using a grid. Right? So that was what he said, I've got. And I said, that's very interesting, but anybody will be able to do it now. What advantages does that give you? And he said, we've been applying it to very interesting problems in engineering. And introduced a second professor who is the world's leading expert in optimization. Still is the world's leading expert in optimization. And he told me the day he signed over his intellectual property to this company, he said to me, you know, I've just given you my life's work, please look after it. And then he broke down in tears. Okay, these things can be emotional. And the third piece of technology, so I said, that's great, but none of this stuff is usable. And he said, Southampton hosts the UK's Semantic Web Initiative. Now, the UK government had poured £80 million into a new initiative called the Semantic Web Initiative, and it's about semantics. The Semantic Web Initiative basically allows you to change the way you input data, you take it out, so you can be more creative in the way in which you input data or you use the results, visualize them, display them, etc. And so this kind of led to a process. So we had three bits of technology. The Semantic Web Initiative has still had very little in the way of commercial realization. £80 million of UK taxpayers' money has gone in. It's not clear yet what commercialization will come directly out of many of those things, but that's not unusual. The optimization technique was being used by Rolls-Royce and BAE Systems. Two companies in the world were using it, nobody else. That's what it was. And grid computing was being used to provide high-power computing mainly for NASA and for the Met Office to come up with difficult forecasts or dubious forecasts, depending on your point of view, of the weather pattern. Right? For those of you aside again, it's almost impossible to predict weather more than 5 days out, although all the research scientists would like to claim it is, because it means they get more grant funding. There are inherent processes, stochastic processes in the upper atmosphere, which mean that you can't predict more than 5 days out with any kind of regularity. But, so interesting, three pieces of technology. So what do you do with them? And the act of creativity came in an interesting workshop, an informal workshop in a pub in Southampton. We were kicking the stuff around saying, well, what can we do out of it? They said, so far you've ripped everything to bits. What do you think we could do? And the answer was, is there a marketplace that we can think of that might benefit from this? And at that point, the optimization guy said, you know, SMEs, small, medium-sized businesses in the UK, would give their right arm to have this kind of capability. So I said, could we not create a service that could be delivered to these people? That, of course, interesting idea, and already the objections started coming through. It's too complicated, there are integration issues, how do you knit it all together, they can't afford it, what's the business model, how do you deliver it? And this thing you're seeing as the elevator pitch was the first slide that we wrote to present to investors for what we were going to do. We turned up and said, this is what we're going to do, give us lots of wheelbarrows of money to do it. Okay, and so the idea was engineering, design, analysis, and optimization available over the web. And we said you can provide access to high-performance grid computing clusters. We're going to reduce competition costs by a factor of 10 to 1. Okay, that was actually, it turned out that was a conservative claim. And we'll significantly reduce design time. And we'll improve optimization. And then the other thing we said was, that's great, that's all the technology we'll do. We're going to change the business model. You're going to pay as you go. You'll only pay for what you eat. We're going to go for a mobile phone model for sophisticated high-end engineering design. And they laughed at us. Yeah? And we said, it's going to be available to all, you know, and they say, oh, these guys can't afford it, they know how to use it, they'll never pay for it. We said, well, that's where the market is. So that was active creativity. So with the key technology building blocks I've told you about, tools, semantic tools, high-performance grid, and optimization. And then we said, well, let's just try and understand where this thing fits. Who else is doing what in that space? And we began to understand that one of the creative innovations was knitting several technologies together. If we looked at any one technology, there were people doing their own thing in that space, and there were competitors. And it was in integrating all this together where the gap lay. Yeah? And then you'll see some of the tiering there was about the size of the customer. So there were people trying to do this, what we call tier 1, the top tier customers, and they had about 4 customers in the world. We were interested in having tens of thousands of customers, hundreds of thousands of customers all over the world. Okay, and so we said, okay, what's our go-to-market strategy in that case? We're going to focus on those SMEs, and then the ultimate ambition is to basically make the service available to anybody designing at home. So I can envisage a situation 5 years from now where you've qualified a designer and you used to work in a company, now you sit at home and you basically sell your services as a designer because you got this most sophisticated design platform available to you. And just think about how the Industrial Revolution changed structures. This could be like another major restructuring. Okay, right. And so what about marketing and sales then? What do we, and by the way, the reason it's called Geodize in that space, Geodize 2, Geodize was the code name of the project invented by the scientists. And it came from, because they were using it for geographic stuff, and they were using it for ocean modeling when they first started off. And so we said, let's build a community, let's cascade everything down, let's basically go for a viral approach. Let's bypass all the other ways in which people reach customers, going through conventional distributors and channels. Okay, now, very interesting. So how did this exercise in creativity manifest itself? Today, if you type in designforce.com and go online, you can actually use the service. It exists. It has a subscription model. It has a web environment. You see that. It has, and the first node is in fact 400 Dells in a grid platform. I had great pleasure in signing the purchase order to buy 400 Dell PCs in one go with several power supplies, because we basically built our own grid. So we had people, in an afternoon we built our own supercomputer, one grid node. And if we need additional nodes, we ordered another 400 Dells. And if we want to set up a node in India or in South Africa, we pitch up and we buy locally, of course, so we get cheaper prices. And then we usually get the phone call from Dell saying, why are you buying 400 PCs? We do have higher power machines, you know. Yeah? And our reaction to that is, no, we just want those machines. We want the lowest spec machine because we're going to strip out quite a lot of stuff as well. So that's where the service is at today, which is it's up and running. It has novel technology buried under the bonnet, but the user doesn't see much of it. The user knows nothing about grid computing. None of the users even hear the word grid computing, and yet it's a key enabler. Users hear about optimization, but they don't know about the 35 years of applied maths and algorithms that have gone into it. They see a nice little icon that they click on. It says optimize. And the other thing about it is that the semantic technology is not visible either explicitly. Its whole secret is this invisible. So visualization tools. And of course, when you do something like this, you find that the creativity changes the way, so your team becomes very creative. We hired somebody in who'd worked for Microsoft, who came along and said, we should do more visualization of the final results. So when you design a blade, why can't we just rotate it so the designer can see what it looks like, look at how the airflow is looking right around the 3D surface. We need proper 3D visualization. And we said, well, it's quite hard to do. And he said, no, it's not. Why don't we use the tool that the BBC and Microsoft use for IPTV, the Silverlight player? And so we're using visualization technology that comes from a consumer television environment, and it works brilliantly. Another act of creativity. Okay, so that's design force. I guess what I'm trying to do is say to you that there are many, many ways to be creative, but it's about thinking about that. If you ask the investors about the service, they will not recognize any of this creativity at all. Yeah? The creativity they recognize is the one about the business model, which is a subscription model. Because they're sitting there looking and saying, aha, so now you can sign up, oh, you mean you can sign up 200 companies in India over the web? Each of them will pay you £30,000 a year. Oh, that's great. And it's like the Sky model, means you don't have to have a sales force once they're sold in, and all you have to worry about is churn. So different degrees of creativity appeal to different people. And the people who haven't really grasped the area, I think, where we haven't really exploited the biggest impact is in the way you sell it. Because you've moved from a situation where big companies employ sales forces, Microsoft, Oracle, they have teams and teams of consultant salespeople who go and sell the product. Can you imagine a situation where a major engineering company doesn't get a visit from a salesman but goes to a website and signs up? Because why? Because we give them a 30-day free trial to try it. And so what if they design all their products for the year using our tool? Eventually they'll come back to us. Okay? So all that I talk you here about free and not free in content and service starts to apply to business environments. Okay, so I'm going to, at that point, stop and talk about design force. So this has been slightly more professionally produced, and this material was all produced by a team in Mumbai in India, run by a man who's referred to as GS, G. Sundaraman. So these slides are courtesy of GS, and he runs the innovation team for Godrej. And there is a Cambridge connection, which is that the ideas behind this product were hammered out and developed at the Ignite program run by the Center for Entrepreneurial Learning last summer. So it shows you what can do. Last summer, we had one senior manager from Godrej on the Ignite program for 5 days. And where are we? 10 months later, there's a product in the market. Okay? So the other thing about creativity is being able to do things fast. Okay, so this is, again, what you'll see is this is a vision that they started with, which was disruptive innovation, providing a new impetus to change things at the bottom of the pyramid and get at people who weren't typically using a particular kind of product. Yeah? So, January 2007, they conceptualized this product. So this is 2 years before the Cambridge workshop. Yeah, 1.5 years. 1.5 years before. And I'm not sure when the name Chota Cool was chosen, but for those of you who understand Hindi, know that Chota is small, and cool is cool, speaks for itself, I think, and cooling. So basically, the idea was that across rural India, there is a big problem with fresh food being available and distribution of food, because stuff only keeps for so many days, and in the high temperatures. What it means is that the people who do the buying and the cooking, which is mainly women, have to make frequent journeys to the market to buy fresh food, and the way that food is maintained, the entire distribution infrastructure is geared around that. So the idea was to create an environment where it started off as a thought, can we build a low-cost fridge? And the first real breakthrough, for me, was the understanding or the realization that actually people didn't want to make ice in India. They wanted to chill stuff. So the need to take things down to 0 degrees evaporated suddenly, and it became the need to maintain something between 5 and 7 degrees to chill stuff, because that would make a really, really big impact. So all of a sudden, the act of creativity said, you know, the idea of a fridge with makes ice and chills, etc. We just come up with something different. This is a chilling device, not a freezer, because nobody wants to buy one of those. And that, of course, takes a big element of cost out of the whole thing, because you don't have to reply, and also environmental damage, because all the refrigeration cycles and all the other issues go out of the window. And so this is a nice, sophisticated way of saying, you know, talk about in-depth understanding to overcome fundamental barriers to consumption, unmet need of consumers. I've just told you what that actually means, which is realizing you don't need a fridge, but you need a chiller. Okay? And then the next thing was basically, how do you design and build a physical how can you take this idea and do something? And so they had people designing space, and so they came across next act of creativity was saying, why all these devices, chillers and freezers, front opening? Why? Because, you know, it's at this sort of height, it's easy to open, but from the ratio of a packing ratio point of view, how much material you can get in, a front loading device is very inefficient. If you talk to a mathematician, he'll show you a nice little algorithm which shows that top stacking systems are much more efficient packing arrangements than side opening systems. Okay, it's a big realization which said, okay, so this thing's going to be top loading. We're going to have to re-educate the consumer to load their stuff in from the top rather than from the side, because we can get a lot more usage. In a typical refrigerator, the space utilization is about 70%. In this, it's nearer 90%. Another act of creativity that was. So now we're talking about then the options for business model. So I won't go into the detail of this, but the whole idea was we're going to get the price down and how we deal with that. And they had a price point they had to hit. And I think the price point was 4,000 rupees, which translated is what, 70 pounds? In fact, 65 pounds, depending on the exchange rate. And they've actually met that and gone slightly below that now. Because that was the magic point at which they thought hundreds of thousands of people would buy this device and use it. So it basically combines a number of things. So what is this? Top opening. So they now had a nice argument which said it's top opening so it conserves the cold air, because, you know, warm air rises, the cool air stays at the bottom, which is true, but actually from a thermodynamic point of view it's not a bit of sales pitch. So, you know, it opens the top so it keeps the cool in. Solid state thermoelectric cooling, okay? Piezoelectric technology, little heat pump. So the cooling is actually in the lid. That lid actually has a cooling chip in it, that's all it does. So no compressor, no refrigerants, no moving parts, whisper silence. So it's very quiet because there's no compressor. It's a static set of components. It works off 12-volt batteries. Again, big impact. So you can operate on a battery or an inverter if you want. Very low power bill, another big plus for people. And plastic body, so no rusting. You know, I remember seeing I saw the prototype boxes a few months ago, and then I saw the final production unit in Mumbai in March. And it's quite interesting. You think, my God, is that, you know, it's a little plastic box with a plastic lid, and in the lid is this insert for the cooling. Very, very simple, very easy to move, and it has a temperature range that's different. So now this is quite interesting because they were really talking about how it's distinctly different. So different science. So we talk about the Peltier effect for cooling, and different technology. So it's based around semiconductors. It's essentially a heat pump on a chip, on an electronic chip. That's what it is. That's how the cooling mechanism works. And so it has different performance dimension in terms of size, mobility, robustness, has a different structure, and it actually serves a different purpose. So it does something different, but it serves a major need. And then you look in terms of price performance, and usage environment is different. Because it's small and it's sealed, if the power goes off, it doesn't matter so much. And then there's life cycle costs, so absolutely distinctly different. Now, so we started talking to them so Shai Vayakarnam, which some of you know, Shai and I were in India in January this year, and we saw some of the early prototypes, and they were all sitting around in a brainstorming area and saying, we've got some interesting challenges, because they couldn't get the cost of distribution down. Because what they found was the product was great, all the user test people wanted to buy it, but the conventional distribution channels in India take something between 7 and 10% of the price of a product goes to them, which is low. In Europe, it's more like 22 to 27%. So if you go into a retail store, if you go to an electronics store in Cambridge, about 25% of that is actually going to Dixon's or whoever they are. That's why the middlemen are so wealthy in this country. The people who make the products, Sony, others, may only make 3 or 4%. In India, it's 7 to 10%, but that was still, because the price was so low, distributors said, oh, we're not interested. Even with 7 to 10%, we're hardly going to get out of bed. We'd rather sell expensive, high-value products. So they had a problem. They had a product consumers wanted. They didn't have a distribution channel. So we said, why don't you build your own distribution channel and change the cost structure of it? And so they basically teamed up with some NGOs and rural organizations and completely changed the nature of the bypassed conventional distribution completely. And we were shown this van, which is the first prototype van, and had a van with these half a dozen of these things stacked on one side, and the other side they had a display unit and a loudspeaker mounted on it, and it was like a scooter. Well, it was basically like a rickshaw taxi, right? A three-wheeler, and they had the driver, and the driver all women. It was going to be sold by women. They hired a whole team of women, and they basically said, we'll give you 5% of the cost of sale. And these women said, 5%? That's brilliant. Yeah, and you get a vehicle to go with it, and you get all the sales tools, etc. And when they started doing these evenings. They would go around villages in an area, and they held it as a social event. And they would pick dances. In India, there's these things called melas and festivals. They'd pitch up with this van, and they were taking pre-orders. And before the product launched, they had hundreds of thousands of pre-orders just by doing this, because nobody had to pay any money. There was no deposit or anything. Just said place an order. And so they took that and they basically changed the whole distribution environment. I don't know if GS has got some pictures of these vans in here, because they were very interesting. And so the next part, the final part of the story, of course, is now this product's being rolled out. And it's not just the Indian market where it applies across whole swathes of the developing world. And you can imagine one day they might be trying to sell it in Reigate. You can think about when you think about the model, the distribution model, it's very creative, but it's not actually that new. In the 70s, 60s and 70s, there were these Tupperware salesmen, there's the plastic utensils that were sold. And the Tupperware salesmen were all women who did as a part-time job to earn extra money for their families. And they would go around door to door, they would have Tupperware parties, invite their friends in. This is just a scaled-up version of the same thing. You go to a village, you have a party, you invite everybody, and you sell these things off the back of your van. But it's fundamentally changed the pattern of distribution. So that's another very different way of looking at creativity. And it's not actually that high-tech. So, okay.